Hey everyone, welcome back to another video of Tau Club. So today we're going to be discussing the fundamental principles of quantum physics. Quantum mechanics. Okay. So what is quantum mechanics, right? Quantum mechanics is the study of everything small, you can say. It is a study of atoms and the subatomic particles within the atoms, or specifically what makes up the proton and neutron, and how does the electron behave. So you might recall that in our first video we talked about the Heisenberg uncertainty principle. And this is a crucial thing if you want to begin to learn about quantum mechanics, that you understand what this principle states. Right? So what does it say? Basically says that you cannot know the position and motion of an object at the same time. And we also talked about in lesson 1, the advanced concepts, about how an electron has wave-particle duality, or it can act as both a wave and a particle. So now let's talk about an important concept in quantum mechanics. The first one of these is superposition. So what is superposition? Is it like being Superman or being in a Superman position or something? Well, no. The fundamental principle of particles at such a small scale basically states that these particles can be doing two things at once. Well, you might be thinking, I can do two things at once too. I can eat and watch TV at the same time, right? Well, that's not what I mean. By two things at once, let's say you're turning to the right, right? And then you're turning to the left. But imagine you're turning to the right and left at the same time. And that's one of the more interesting concepts in quantum mechanics, that with superposition, a certain particle can be having two different spins at the same time, right? Two different rotations. And you can do various stuff with that, and that's very useful in computing, which we'll get to in the next video. The next concept is quantum tunneling. Quantum tunneling basically states, right, that you have an object and you have a barrier like a wall, but that object comes next to the wall, right, and just suddenly appears on the other side of it and can continue on. So you're like, what does this mean, right? So imagine you throw a ball at a wall. You expect it to bounce off and hit you, correct? So you throw a ball at the wall, you expect it to bounce off and come back. But instead of bouncing off, it just suddenly appears on this side and continues. That's what quantum tunneling is. It tunnels through this barrier. How? It's basically like teleportation. And that happens due to quantum fluctuations and so on. But just know that for the basic concept, that happens. Remember when we talked about nuclear fusion in stars? Well, quantum tunneling is used in that sense as well. Because the two nuclei of two atoms, right? They all have these protons which are positively charged, correct? And positively charged particles don't want to be near each other, right? They repel each other. So they're going to go apart. So how do they collide and form new atoms in the course of stars? Well, that's because of quantum tunneling. These two are like this, and suddenly this disappears and this proton appears here. And so this is the basic principle of quantum tunneling and how it's useful in everyday life, right? And we'll get to why it can be an obstacle for making the computers that we use today. Lastly, one of my favorite, quantum entanglement. Let's talk a bit about quantum entanglement. Now imagine you have two best friends. Let's call them Polly and Q. These friends are so connected that if Polly dyes her hair blue, Q's hair instantly turns blue too, no matter how far apart they are. That's quantum entanglement. In the quantum world, particles can get entangled, meaning their properties, like spin, become linked. If you change the spin of one particle, the other's spin changes instantly. Picture Polly's spin changing from positive to negative. Q's spin switches to negative at the same moment. Now here's the mind-blowing part. This happens even if Polly is on Earth and Q's on the other side of the universe. Billions of light years can break their bond. This is quantum entanglement. Spooky action at a distance, connecting the cosmos in ways we're only beginning to understand. So that's a very weird thing, right? It's impossible to understand because if even across the universe it happens instantaneously, then there must be some message traveling faster than the speed of light to reach the other particle and let it know the position that this particle has. Well, the theory of relativity by Einstein says that nothing can go faster than the speed of light. So it's a very ununderstood concept in general, but we still use it today. It's used in many things from your everyday laser to even your computers, right? So Einstein called quantum entanglement spooky action at a distance because he could not grasp it. But it's a very useful concept for today's technology. So these are the fundamental three principles of quantum mechanics. I hope you've understood this. Do some research if you're interested more, especially on quantum entanglement and stuff. And I'll see you for our next video where we apply these to quantum computing. Thank you very much.